Okay, let's move on to question 2.2. Again, we're still working with area and volume, and this one is slightly more complex, but again, we'll get through it, right? So let's read the question. The organizers of the fashion show decide to hand out chocolates to the audience at the entrance. The pictures and diagrams below show the two different containers in which the chocolates will be packed. Okay, so here's two pictures, and here are the dimensions, right? So over here, they give us height, but they don't give us A, right? But they do give us volume. Here, they give us the height, and they give us the radius, but they don't give us volume. So we're really thinking to ourselves, we're probably going to have to work out A. We're probably going to have to work out the volume here. So we really kind of know what's going to be asked, right? Again, if you don't understand these scenarios up front, go to the questions. They really do help us understand what's going on. Okay, first question. Determine A, the length in centimeters. Remember, always you have to make sure that your measurements are correct and according to the question. Of one side of the square, right? You may use the following formula. The volume of the box with a square base is side squared times by height. Okay, so let's start here. We have the volume, so we have this already. Okay, so we know that our volume is the height times that side times that side. Okay, and what are we asked to find? We asked to find the length of one of these sides. Now, this side here, let me just get a highlighter so it's a little bit easier to see. This side here is going to be the same length as this side here. So firstly, what we're going to do is we're going to strip out the height, right? So effectively, we don't want the height included in the volume. And if we take this amount and we divide by the height, we then just left with the area of the bottom, right? So remember, volume equals length times base times height. And we know that area just equals length times base. Times base, right? So if we divide volume by height and we take out, by height and we take out height, do you see how it becomes area? And that's what I mean by that. Okay, so let's go and write this down. It is 4 marks, so it's a fair amount of working. So let's go and do it. So we're going to say volume equals 3,456 centimeters cubed. Okay, so we know that. Let's now go and strip out the height, so divide by the height. Now, careful here, right? The height here is in millimeters. We need it to be in centimeters because whenever we're working with area or volume, we need our units to be consistent, right? So let's convert that first. So we're going to say height equals 240 millimeters divided by 10 to get into centimeters. So it's 24 centimeters. Now we can work with it. Now we're going to say 3,456 divided by 24, right? Put that into your calculator. So it's 3,456 divided by 24, and it's going to be 144, right? Now you could be saying, well, what's this 144? What are we actually saying? Well, the 144 is actually just the area of the base, right? Remember I said when we divide by height, we get to the area. So we know the area of the base equals 144 centimeters squared, right? Why is it only 2 now? Because we have divided by the height. So we're only taking 2 dimensions into consideration. So that's why it's to the power of 2. But they didn't ask us for the area. They asked us for the length. Now, we know a square has equal sides. And we know that this 144 is just this side here times by this side here, okay? So we just know, right, that we can square root it, right? You can square root this, put that into your calculator, and you'll see that it is 12 centimeters, right? So, sorry, that's not area anymore. That is the length, that's area, and this is the value of A, right? Don't get confused here. That's the area. This is the value, right, of A. And you could be saying, well, how do I know to square root it? Well, remember in the square, right? And that's why this is called a square number and why you square root it, because what you're doing is you have 2 sides that are exactly the same in length. So in order to get one of the sides length, you have to square root, right, 144. If you don't know where that is on your calculator, there it is there, 144, and it equals 12. Now, if that's 12 and that's 12, times those 2 together, it gets you back to your area. And that's why it's called a square root, because it's actually going back to the shape of a square. Okay. So not an easy question, but not too bad. Let's now continue to the next question. It says, the organizers of the fashion show want to use their own label around the outer curved side of the cylindrical container. So we're talking about this one now, right? The label will be 1 centimeter longer than the circumference of the circle. of the circular base to allow for overlap. So basically you have a label, right? There's a label, and then you're going to wrap it around, and there's going to be a little bit of overlap like that. So it's going to be a little bit longer than circumference. So they want you to find the circumference of it and then add 1 centimeter for that little bit of overlap there. Because remember, circumference is not overlap. There's a little overlap. Okay. So then it says determine the total area to the nearest centimeter squared of all the labels that will be required for 76 cylindrical containers. Okay. So you may use the following formula. This formula here, be careful. When I first looked at this, I thought this was an L, right? So it's not an L, right? Otherwise, you're going to take an L there if you think that that's an L, right? That is a 1, right? So it's a 1 there, plus 2 times pi times r times height. So we actually have all of these values. So that's going to be the area of 1 label. But we have to get 76. So be careful. There's lots of things to do here. Again, 4 marks. So lots of things. So let's go find the area of 1 label. Okay. Area of 1 label. Okay, so the area of 1 label is 1 plus 2 times pi. So remember, this pi next to the 2 means multiply. I know that a lot of you just want to put pi into your calculator, but do you see they've given us a value of pi? So please make sure that you use the value they give you. If they don't give you a value, just use the one on your calculator, which is over here, right? Shift, there's pi. But because they've given you a value, use that value. Okay, otherwise you'll get mark taken off. 3.142 times by r. What is r? The radius, so in this case is 7. We know the radius there is in centimeters, so we're happy with that. And then we're going to times by the height, which is 24, also in centimeters, so we're fine. So we actually can see that the height of these two shapes, right, is actually the same. They're both 24 centimeters, even though that looks more, but that's actually measured in millimeters. Okay, so there's that. And let's put that into our calculator. Be careful to make sure that you do your brackets correctly, because that is a space where students seem to slip up. I also seem to slip up there, so it's not just you if it's something you struggle with. So the area of 1 is 1479.712 centimeters squared, right? But it didn't ask for centimeters squared for just 1. It asked for all of them, right? So you're going to have to go and do all of them. So how many labels were there in total? Okay, there were 76. So you're going to have to times this here by 76. And there is your answer there. Okay, so I'm going to say 1079.712. Please don't round off. Remember, we only round off at the end. Times 76. I put that into my calculator already. You should be able to see that. 82058.112 centimeters squared. Okay, let's see if it told us to round off to a certain number of decimal places. It says the label will be 1 centimeter longer. Determine the total area to the nearest centimeter squared. Right, so now we need to round off. You can't leave it like this. How do I round this off? Well, remember, it didn't say round it up. It just said round it off. Because we see that this 1 here is less than 4, right? It's below 4. We're going to say, well, that then is 82058 centimeters squared. And that is our answer. Okay, so just be quite careful in doing these questions, because you don't want to lose marks for doing silly errors like that. Okay, so we've got 8 marks so far. Let's go on to the last 2 questions. So this one says, show with calculations that the volume of the cylindrical container, so that container, right, is that much more than the volume of the square container. So basically we're proving that more there's more space in this container than this one. Okay, so we know that the volume of this is already that, right? So we've got the volume of the sort of square container, so we don't need to do any work there, but we do need to find the volume of that container. So here it says the volume of a cylinder, right, which that is this. So let's go work out the volume of the cylinder. 2.2.3. So the volume of the cylinder is going to be pi. Here, be careful, right? They've given you pi again, so don't just use your calculator's value. R squared, which is 7 squared, times height, which is 24. All of that's in centimeters, so we're happy. All we need to do now is put that into our calculator, and we are done. There we go. So 3694.992 centimeters squared. No, not squared. Power of 3. Okay, because it's volume. So now that's the volume of that. We need to then work out the difference. Now we need to say 3694.992 minus 3456. Where does that come from? That's that there. So we're basically proving that volume is larger than that volume. So put that into your calculator. 3456, and it is that many centimeters larger. Okay, which is what they asked us to prove. Remember, you could be saying, oh, but there's a 2 there. You generally round off to 2 decimal places. There's your answer there. So we are done. Okay, let's then do the last question, and then we're done with question 2 in its entirety. 2.2.4, state the most appropriate metric unit of measure for the mass of a container of chocolates. Now, it depends how much you like chocolates, I guess, but in general, I would say grams. Okay, so you can say 2.2.4, and you would say grams. Now, some people would argue kilograms, and the memo does allow kilograms, but I just feel like that's quite extreme. I don't know why you'd be eating so many chocolates, but you know, if that's what you want to write, that's okay. Okay, so that is question 2 done. We're going to go on to question 3 now.